In the quiet halls of early 20th century physics, one man dared to ask a question that would shatter our understanding of reality itself. What if everything we thought we knew about the atom was wrong? This is the story of Niels Bohr, the scientist who stared into the heart of matter and saw not a miniature solar system, but a world of impossible leaps and quantum chaos. The year is 1911. A young, ambitious Dane named Niels Bohr arrives at Cambridge, hoping to work with the legendary J.J. Thomson, the man who discovered the electron. But Thomson is unimpressed. Bohr's ideas are too radical, too strange. Disheartened, Bohr moves to Manchester to study under another giant, Ernest Rutherford. Rutherford had just discovered the atomic nucleus, proposing a model of the atom like a tiny solar system with electrons orbiting a central core. But this model had a fatal flaw. According to classical physics, those orbiting electrons should be constantly losing energy, spiraling inwards until they crash into the nucleus. Atoms should collapse in a fraction of a second. Yet, the universe and everything in it was clearly stable. Why? This paradox consumed Bohr. He would pace for hours, lost in thought, wrestling with a problem that defied the laws of Newton and Maxwell. He realized a new kind of physics was needed. One night, a conversation about astronomy sparked a revolutionary idea. What if electrons weren't free to orbit wherever they pleased? What if they were restricted to specific, allowed energy levels, like planets locked into their orbits? And what if they could jump between these levels instantly, without traveling through the space in between? This was the quantum leap. A concept so bizarre, so counterintuitive, it bordered on science fiction. When an electron jumped from a higher energy level to a lower one, it would emit a photon of light with a specific frequency. This single, elegant idea explained the mysterious spectral lines of elements, a puzzle that had baffled scientists for decades. In 1913, Bohr published his model of the atom. The physics community was stunned. Albert Einstein himself called it the highest form of musicality in the sphere of thought. But Bohr's work was far from over. The quantum world was getting weirder. He became the intellectual sparring partner of Einstein, engaging in a series of legendary debates about the nature of reality. Einstein, who famously said God does not play dice, couldn't accept the inherent randomness and uncertainty that Bohr's quantum mechanics implied. Bohr, on the other hand, embraced it, developing the principle of complementarity, that things like light could be both a wave and a particle at the same time, depending on how you observed them. Reality, he argued, was fundamentally fuzzy until it was measured. As the world spiraled into the darkness of World War II, Bohr's life took a dramatic turn. When the Nazis occupied Denmark, Bohr, whose mother was Jewish, was in grave danger. He was a Nobel laureate, a titan of science, and he held a secret knowledge that could lead to the most powerful weapon ever conceived. In 1943, the Danish resistance smuggled him out of the country in a fishing boat. He was then flown to Britain in the unpressurized bomb bay of a Mosquito bomber. The pilot told him to use an oxygen mask when they reached high altitude, but Bohr's head was too large for the helmet. He passed out from lack of oxygen and nearly died. An ironic twist for a man who had spent his life exploring the voids of the quantum world. He eventually made it to America and was brought to Los Alamos, New Mexico, to consult on the Manhattan Project. Here, surrounded by the world's top physicists, Bohr saw his abstract theories taking on a terrifying, physical form. He was a reluctant participant, horrified by the weapon's destructive potential. He spent the rest of his life advocating for nuclear transparency and international cooperation. a wise man who understood the immense responsibility that came with his revolutionary discoveries. But here is the final, mind-bending twist. Bohr's model, the one that won him the Nobel Prize and reshaped science, was wrong. Or rather, it was incomplete. We now know that electrons don't exist in neat, circular orbits at all. They exist as probability clouds, smeared out waves of potential, a ghostly haze of what if and maybe. The very idea of a place for an electron is meaningless, and yet, without Bohr's brave, impossible leap is beautiful. Flawed model, we never would have taken the first step into that strange and wonderful quantum universe. He built the ladder, and even though we kicked it away, it was the only way we could have ever reached the stars. Thanks for watching. If you enjoyed this journey into the atom, make sure to subscribe for more stories that shape our world.